Hello, ladies and gentlemen, and welcome back to the 2001 Fermat paper. We're on to question number 9, and hopefully you've given that a little bit of a go before you come in here and watch this video. So question 9, what does that say? A bag contains 20 candies. 4 of them are chocolate, 6 of them are mint, and 10 of them are butterscotch. Candies are removed randomly from the bag and eaten. I could go for some candies right now, but we're doing a math contest, maybe later. What is the minimum number of candies that must be removed to be certain that at least 2 candies of each flavor have been eaten? Okay? So the key word, and they've actually italicized it here, is certain. Okay, we have to be certain. And that gives us a little bit of insight into a strategy. If we have to be certain that at least 2 candies have been eaten, then no matter, how do I want to phrase this? We have some potential answers here. 6, 10, 12, 16, 18. Let's suppose the answer were 10. If I have to be certain that at least 2 candies of each flavor have been eaten, and 10 is my answer, then there has to be no way to draw out 10 candies from this bag and not have taken at least 2 of each of the flavors. Okay? So if I can find a way to grab 10 candies out of this bag that don't contain at least 2 chocolate, 2 mint, and 2 butterscotch, then I'll know 10 isn't the right answer. Okay? I know it says randomly, but if we have to be certain, then that means no matter what random chance gives us, no matter what possible candies are taken, we need to be able to be sure that at least 2 candies of each flavor have been eaten. Okay? So we get to sort of, I guess, play devil's advocate a little bit and say, oh, you think the answer is 10? Well, what if I took all 10 butterscotches out? That could have happened. All 10 butterscotches could have been grabbed out and eaten, and I am getting quite hungry. And that would have left 4 chocolate and 6 mint, so we wouldn't have eaten at least 2 chocolate and 2 mint. Okay? So if I can find a way to take 10 candies out that doesn't give me the condition I'm looking for, then I'll know that 10 can't possibly be the right answer. Okay? So let's have a little bit of a go at it. Let's write that out in some words. Now I don't know what the answer is, so I'm just going to give him a name. Since we're certain that at least 2 of each flavor, you know, I just noticed I spell flavor with a U, obviously, because I'm using Canadian English. It's a Canadian paper. Do they spell with a U, or have they fallen to Americanization? Hey, they spell it with a U. Canada Pride worldwide. All right, so 2 of each flavor. There must be no way to take out X candies So 2 of each flavor. That includes chocolate, mint, and butterscotch. Okay. So if X is a solution, and that means there's no way to take out X and not have those. Then we know X can't be the right answer. Okay? If X were the solution, then because we're doing this randomly, there must be no way to take X candies out of the bag and not have taken 2 of each flavor. So if we flip that around, if we can find a way to take out X candies and not have at least 2 of each flavor, then we know X can't be the answer, because what if we randomly took out that amount? So we'll do a quick example. The reason I'm going through this so slowly and actually writing things out is because this is actually a really good question in terms of logic and thinking. Okay? This isn't about algebra. This isn't about manipulation of variables. This isn't about how many of the different centers for a triangle do you know. This is, can you think through this clearly and do some logic? Okay? What would the answer look like? Okay? If we have to be certain, that means there is no way in the infinite possible, not infinite possibilities, but in the any possible random ways to take out candies that we wouldn't get 2 of each flavor. Once we realize that, and we flip it on its head, the contrapositive, if we can do this, if A, then B, so then if we can't do B, then we must not have had A. Yeah, it's contrapositive. Yeah. So we'll just do a quick example here. Because it's hard for me to, because I know you guys, you might have questions and I can't answer them because it's a YouTube video. So it means I pre-recorded this. This happened a long time ago before you see it. So let's just make sure that the logic is clear, because I would say this might be one of the more important questions to understand on the contest. So maybe even if you're not clear with this, go see their solution. Maybe they go through it a little bit with a flavor of logic. So take X equals 3. No, let's make it a more plausible answer. Take X equals 6. I think that was A. That's the first potential answer. So we could have taken all 6 mints. Or maybe 4 mints, 1 chocolate, and one butterscotch. Right? These are possibilities. We could have taken these out. Right? So we could have done this, and so we can't be certain. Right? You're going to tell me 6 is the answer. No matter how I draw 6 candies out of the bag, I should be able to have at least every possible way should give me at least 2 chocolates, at least 2 mints, and at least 2 butterscotches. But we've found at least 2 ways that it doesn't work. If you take all 6 mints, you haven't taken at least 2 chocolates or at least 2 butterscotches. Or if you took 4 mints, 1 chocolate, and 1 butterscotch, you haven't taken 2 of each flavor. Since we could have done them, we can't be certain that we didn't do that. Okay? So therein lies the logic behind the question. So I've written it out, I've done an example. Now let's actually answer the question, because maybe that's just what you came here for. Okay? So let's actually answer. We have so we have 5 possibilities. 6, 10, I think one of them was 12, 14, and 18. Was that it? 12, 16, and 18. So we're not going to perform some calculation and realize, oh, it's got to be 16 or something like that. What we're going to do, since we're looking for the smallest number, we're just going to go from lowest up to highest and see if we can rule them out. Okay? So definitely 18 should work, but is it the smallest number that guarantees it? So we've already ruled out 6. How? We could have taken all 6 mints, and that wouldn't give us 2 of each flavor. Since there's at least one possibility, we know 6 can't be the answer. For 10, we could have taken all 10 butterscotch. Right? There are other ways we could have taken out 10 candies and not taken out 2 of each. We could have taken the 4 chocolates and 4 mints. Then we wouldn't have had at least 2 butterscotches. But all we need is one. We just need one way of drawing out candies that doesn't work, and that collapses the whole thing. So the answer is not 10. How about for 12? Well, if you haven't realized the logic behind this situation, now that I've explained it to you, maybe stop and think, reread the question, pause the video. See, is there a way you can think of to draw out 12 candies from the bag that doesn't guarantee at least 2 chocolate, 2 mint, and 2 butterscotch? Seriously, pause it for a moment and try. Just explore a little bit. Alright, I'm going to assume you've tried it. Now, hopefully you found an answer, because I know I certainly did. There's definitely a way of drawing out 12 of the candies and not getting at least 2 of each flavor. Okay? How do we do it? Well, let's find out. We could have, and my answer might differ from yours. Could have randomly drawn the 10 butterscotch candies and let's say 2 mints. That's a total of 12 candies drawn, and we don't have at least 2 of each flavor. We definitely have 2 of the flavors, but we have no chocolates at all, let alone 2 chocolates. So that means not 12. Okay? So another one was 16. Again, if you want to, quickly pause the video and try. Can you figure out a way to get 16 candies out of the bag that does not get at least 2 of each flavor? And yes, there is. Very similar to the last one. 10 butterscotch, 6 mint. That's 10 plus 6. That's a total of 16 candies. And again, where's the chocolate? Now, 18 is the only one that's left, so it's got to be the right answer. But let's just stop and think. Is there a way to draw all these 18 candies out of the bag and not have taken 2 of each? Well, if we took all the butterscotches and all the mints, that would be 16. Then we'd still have to take 2 of the chocolates, and that would have 2 chocolates, at least 2 mints, and at least 2 butterscotch. So that doesn't work. And in fact, it certainly won't work any other way. Okay? So 18's sort of got to be the answer, just by process of elimination. But we can also think about it another way. Okay? If we are picking out 18 candies from the bag, then we're going to have 2 candies left over. Okay? Is there a way to choose those candies, maybe say in one particular category, like butterscotch or chocolate, and force it so that that takes up more than the number of candies minus 2 in that category? Okay? So no matter what 18 we choose, there's going to be 2 left over. If there's a mint or a butterscotch, if it's mint and butterscotch, for example, then we know we've taken 5 of the mints and 9 of the butterscotch. That's at least 2 of each, and we'll have to have taken all the chocolates as well, and that's at least 2 chocolates too. So if we think about it, 18 will work. Now, a better question is, we didn't get 17 offered, but is there a way to make 17 not work? Or is there a way to make 17 work? And that's something for you to explore. But 18 is the answer by process of elimination. You can also show it's got to be the answer by eliminating 17 as well. So I don't need to actually do a case for 17. So 18 is the answer. By process of elimination. Okay? So, sorry I took so long with this question, but it is a nice logic-based question. And 18, I believe, was E. And so I really wanted to get across the reasoning. Because you can be good at calculations as much as you want. But if you can't reason, if you can't employ logic, if you can't say, well, if you've got A then B, and you have not B, then you should have not A as well. Little basic just reworkings of certain conditional statements, things like that. Then you're going to be quite stumped when it comes to problem solving, because there's a good chunk of problem solving that really is about logic and working your way and reasoning your way through scenarios, ruling out other ones, and including some things, forming organized lists so that you know you don't miss certain examples of things, stuff like that. Logic and reasoning, very, very important to problem solving. I would say as important as your basic arithmetic and your basic understanding of algebra. So I did go over, not over time, but I did spend an overly long time at the start there, but I would say it's worth it. And, if you're having trouble understanding it, leave a comment. Maybe someone else who stumbled upon the video can explain it better than I can. I know I'm not the best teacher in the world, but I hope I got the idea across to some of you. But that does it for question number 9, I think it was. Yeah, question number 9, and we're going to move on to question number 10, which is a little less logic-y. So if you didn't enjoy my explanations at the start, then question 10 is going to have none of that. So I'll see you for question number 10 on the 2001 Fermat in the next video. Thank you so much for watching.